All right. Sorry to have to make this one in two parts. Sometimes it's just as I'm recording, something happens, things like that. So we're just going to continue on talking about all of the important characteristics of these polynomials. So let's go ahead and start with the degree here. The degree comes when it's not in factored form, but when it's in standard form. So you have to think about multiplying all of this out. The next thing is you don't actually have to multiply it out, but you have to think about what's going to happen with the x's when you do multiply it out. So for example, this is an x plus 2 to the power of 3. When you multiply that out, the highest power there is going to be an x to the power of 3, which means you're getting an x cubed coming out of just this factor set right here. This x minus 6 squared, if you were to multiply out x minus 6 times x minus 6, you would see an x squared come out of that piece. And then the last piece, this is x plus 6, that's to the 9th power. Sorry if you can't see that, to the 9th power. And if you were to multiply this all out, you would end up with an x to the 9th at the beginning. And so we can think about this as x cubed times x squared times x to the 9th, which means that you can just add those exponents together and get x to the 14th for your highest power. So the degree of this polynomial is 14. So what we can do is essentially we can count the number of x's that we have in factored form. So because of the cube, there's 3 here, 1, 2, 3, 4, 5 from the square, and then 9 more here. And so that would give us a grand total of 14. The leading term is going to be the coefficient in the front. When you multiply all these out, you will get the x to the 14th. And so now we're asking what is the number that comes directly in front of that? And that's going to be from this value right here sitting in the front. There's a negative 5 in the front. And so what's going to happen there is it's going to be negative 5 times x to the 14th. So your leading term is negative 5x to the 14th. Notice it doesn't say leading coefficient, it says leading term. And so because it says term, you include the x to the 14th as well. If it just said leading coefficient, we just put negative 5, but since it says leading term, just be careful with that. All right, next question. From smallest to largest, list the zeros. And so the zeros are what makes each of your factors equal to 0. So from this first one, you're going to have negative 2. From the second one, you'll have positive 6, and from the last one, you'll have negative 6. And it says put them in order, smallest to largest. So it'd be negative 6, then negative 2, then 6. You don't have to write them as coordinate points because they're not x-intercepts. And then it says their multiplicities are blank, respectively. So you have to go in the order that you put them in here, not the order that they're listed in your equation, but the order that you put here. So the negative 6 came from this factor. Its multiplicity is 9. The negative 2 came from this factor here. Its multiplicity is a power of 3, so multiplicity 3. And then the 6 came from this factor here, so multiplicity of 2. All right, and then the next two questions ask where does it turn and where does it cross? And this is all about the multiplicities. So this, it turns if it's an even multiplicity. And then it crosses if it's an odd multiplicity. And so what we'll see is we'll see it turn at this one here at a multiplicity of 2, and the 2 came from the 6, so it's going to turn at 6, and you could do that by looking up here as well. This is the only factor with an even power, so that is the only place that it's going to turn at. In terms of turn, you could also think of it as bouncing off the graph as well. It's going to cross when it has all odd multiplicities. That's going to be these other two, so that's going to be these two zeros. Or you can look at it here and say, hey, that one's power of 3, that one's power of 9. Those are odd numbers. So at negative 2 and negative 6, it will cross. You should be able to put these in any order because it doesn't give you anything specific. All right. Up next, we have another problem just like that. So first of all, I'm going to rewrite it so that you can actually see what the problem is. All right, so we have a negative 7 in the front. And then on that squared term, it's going to be a t plus 7 in there. T plus 7 squared. And then you'll have the t minus 6 to the 5th and a t minus 8. Sorry about that. So that's what that actual equation is right here. And so I suggest that you hit pause and try this one on your own based off of what we did on the last problem. See if you can pick out all of the important pieces of information. And then go ahead and play, and we'll go over it with you. All right, so the degree is the number of t's that you have here. So this one, because it's squared, there's going to be 2 here. From this one, there's going to be 5, so it'd be t to the 5th, 5. So right now we're at 7. And then there's just 1 here because that doesn't have a power on it. It's just a power of 1, so that would be 8. So the degree of this polynomial is 8. The next question says leading term. So we are going to have the x to the 8th as the degree in here, and then we need the number that's going to be in front of this. Well, in front of my polynomial, all those factors, I have a negative 7. So it'll be a negative 7, x to the power of 8. From smallest to largest, the zeros. So your zeros are negative 7, 6, and 8. And then putting them in order would be negative 7, 6, and 8. And the multiplicities are 2, 5, and then that one is a 1. Don't leave it off. It does have a multiplicity. It's just a multiplicity of 1. So if you need to put a little power of 1 on those to help you out, then that's fine. All right, turns, that's where it has even multiplicities. Crosses is the odd multiplicities. And so the even multiplicities, you can either go based off of what you wrote here, or you can go back to your factors. That has an odd power on it, that factor, so it's going to turn at negative 7. The other two are odd, and so it's going to cross at these two, so it crosses at 6 and at 8. All right, up next, we're going to write a couple equations. So instead of you getting the equation and having to put out all the important information, they go ahead and give you a graph of a polynomial, and they want you to go ahead and write an equation for it. So it says, determine an equation for the pictured graph. Write your answer in factored form. Okay, factors, right? Factored form. And assume the leading coefficient, so the number here in the front, is either 1 or negative 1, one of the two. You should be able to determine by looking at the graph, and this is going to be based off of your end behavior. So, based off the end behavior of this graph, it's going down on the left and down on the right, and we know that means that there has to be a negative in the front. If you're not sure what I'm talking about, is I'm referring to these end behaviors. So because my function is going down and down, the leading coefficient has to be a negative. So you're just going to put in negative 1 in that case. If it was up and up, it would be positive. And then if it was a odd power, or you saw the two ends going opposite directions, you would just match your ends here for positive 1, negative 1. All right, so we know the negative because the two ends go down. How do we figure out the factors? Well, the factors is where the x-intercepts are, right? Comes from the x-intercepts. And so where does it cross the x-axis? It crosses at negative 2. It crosses at 0. And it also right there at 1. And so you're going to put these into factors. So it'll be x plus 2. X, you can say x plus 0, you can say x minus 0, you can just say x, you can put the x in the front, so instead it would look like this. That's the more appropriate way to write it if it goes through 0. And then the last one is at 1, so it would be x minus 1. And then last but not least, you do have to put multiplicities on these. Because it crosses through here, this is an odd multiplicity. And you can just go ahead and put it as a 1. See how it just goes straight through? There's no like funny business. It's not curving or anything as it goes through. So because there's no curve thing happening and it just crosses through, multiplicity of 1. So you don't have to add the power there. You can just leave it because it would have multiplicity of 1. At 0, same thing. It is just crossing through there at 0. So it also is odd and has a multiplicity of 1. And then this point right here, this x-intercept, this is where something different is happening. If you notice, it comes up and it touches it, and then it turns around and bounces. So it is turning or bouncing at that point, which means that it has to have an even multiplicity. And so we're going to put a multiplicity of 2 on it. And that's at 1. So go to your factor where you would have the 1 at and put a power of 2. So your function is negative x plus 2, x minus 1 squared. All right, last problem. It's going to be just like the last one. It says determine an equation for the pictured graph. Write your answer in factored form and assume the leading coefficient is either plus or minus 1. And then it says assume the minimum degree necessary to produce such a graph. If the graph crosses the x-axis at 0, make sure the multiplicity of that 0 is sufficient, blah, 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 right? So what they're just saying is in this thing here is just make sure you get your multiplicities at the right numbers. So if you think you're right and you put a multiplicity of 1 in there, it could have been because I had a multiplicity of 3 instead or something like that. So let's go ahead and write our equation. So it has to go in factored form, so you're going to see some factors. You're going to need a number in the front for the leading coefficient. And so I'm going to start there. It goes up and it goes up. And so since both sides go up, there is a positive 1 in the front. So based off of end behavior, positive 1, which means that you don't actually have to put a 1 in the front because there already is there. So really you just need to put a negative if you're going to use negative 1 and just leave it blank if you're going to stick with the positive 1. All right, and then the factors are your x-intercepts. So it crosses here at negative 1, so I would see an x plus 1. And then it crosses at 2, so I would see an x minus 2. And then you have to pay attention to multiplicities. So at this 0 right here, at negative 1, it does cross through, but it's not going straight through. Like it's not just heading through. It's kind of curving as it goes through. So because of the curve here, you can say that the multiplicity on this will be 3. It has to be odd, but it's not 1. 1 is just straight through. And then the bigger the multiplicity is, the more it curves as it goes through. So we'll say multiplicity 3. So put a power of 3 there. And then this one just goes straight through. So it's a multiplicity of 1. There's no curving or anything happening. So it would be a power of 1. You can leave that power off. So here would be your equation. As you're working through the homework, let me know if you have any questions, what I can help you with.